I'm switching to something else. I'm switching to the system which was given to us, and we were to find out the step response. So it was I'm now going experiment number 5. Okay, so it was s square plus 10s, okay, and plus 100. I'm going to experiment number 5 now, and we are supposed to do this. So if you remember the numerical that we had solved, for that we had solved a numerical in the class, and then I was trying to do the same numerical. I was trying to find all the time domain parameters for that transfer function, and the mistake we were making was we were not taking this 100 at the numerator. We did not do it by this method. That's why all the time responses, they were coming little faster. Okay, so in this case, those who are having the pen and paper and all these things, I remember the time, delay time, rise time, and other thing, it was something in the tune of 1.0. So if you have that, please open it up. So there was a question I had given that something like this, it was there. So underdamped system which was having omega n is equal to 100, and in this case zeta was is equal to 0.5. so in this case, just find out how much is the system response. So just I'm showing you that it is possible and it is coming exactly the same way we had calculated. Okay, the 2 or 3 responses I will show, and you have to actually find out all the other things. So I will give actually a demo of this thing, and that recording, that lecture is still remaining. So that is my part. I'll do that, and I'll just show you. There's a second order response, and that second order response is having rise time, delay time, all those things in the tune of 1.0 something and other things. So this is, we are finding the step response of a second order system, and you'll be finding a peak overshoot like this. If you can just out that calculation in your book, it will be good. So just try to find out. So here also there is a dot problem, and now I think it is solved. Can anybody just find out that calculation? Second order system we plotted. ये हुआ नहीं because time I have set too much. So let us set time less. Let us set time as 4 only, and this is 0.01. So I'll leave you in 3 minutes time. We are having 3 minutes in our hand. Just I'll show you that this is the transfer function you have to plot, and you know the process, and these are the times we are getting. Okay, so how much is the numerical? This was the numerical. Okay, so this was the numerical. This is 100 divided by s square plus 10s plus 100. So this was the numerical. If you remember, this was like this: 100 divided by s square plus 10s plus 100, like this. 2 into zeta into omega n. So omega n was 10. Zeta is equal to 0.5. So 10 into 0.5 is 5 multiplied by 2. So this is 10s plus omega n square 100. So what we are doing is actually 100 divided by s square plus 10s plus 100. For that we are plotting, and we found that delay time was 0.135. Okay, so this is what I'm showing you now. If you see here, delay time is 0.135. This is here somewhere. So delay time is by the time it goes to 0.5. The rise time, so rise time was around 0.242. So rise time is 0.242. I will check it. Rise time is 0.242. Okay, so this rise time is by the time it goes to 1, amplitude 1. This is 0.24. Okay, this is the 0.242. Peak time, how much was the peak time? Peak time was 0.36277. So let us just find out what is the peak time here. So peak time is somewhere here. Okay, 0.36, it should come. Little bit here and there it might happen. So it is coming to be 0.37. These are the 3 things. And peak overshoot is 1.162. You can find out. That means 16.2%. Okay, actually it is 16.3% we had found out. It is 16.3% peak overshoot. These are the values. And there are 2 things. One is TS is equal to 0.8 seconds, and TS 5% is equal to 0.6 seconds. So these are the 2 things I will explain. when I record this thing. Okay, so I had to show you this output. The mistake I had been making was we were trying to plot only for the denominator part. Okay, because we have to actually plot for this transfer function. We don't have to plot for only the denominator, because I'm actually plotting for CT. CT is nothing but the step response of the system, and for the step response we need the whole transfer function. So whole transfer function is 100 divided by s square plus 10s plus 100. So this is the transfer function for our system. Don't look at this type and all these things. This is not in the upper part, you just ignore. Okay, just see only this part, that is ys we have given. This is a closed loop transfer function, 100 divided by s square plus 10s plus 100, and this is a second order system, and we are supposed to find out the step response of this second order system. So what is that? This is 100 divided by s square plus 10s plus 100, ys by s we do. That means there comes three roots of the whole thing. So 100 divided by this, and then we are finding there are three terms that will come in the response CT. Okay, so that response we have found out, and that response we have plugged in here. Okay, so previously also I had done it, so that's why all these things are here. So let us not check this. Now if you are plotting this, you are going to find the second order response. So I will record this lecture today itself, and I will give a MATLAB demo, and I will show you what is meant by 2% settling time and 5% settling time. That is the main thing to observe. Rise time, delay time, peak overshoot, very easily we can find out. Main thing we are supposed to understand is what is meant by 2% settling time and what is meant by 5% settling time. Definition is whenever the waveform is doing some kind of undulation, in that whenever the system output comes in between the 5% error range. 5% error range means nothing but when it enters that 0.95 to 1.05 band. When the response enters that 0.95 to 1.05 band and stays within that, that time is called as a 5% settling time. What is meant by 2% settling time? When the response enters the 0.98 to 1.08 amplitude band and stays within that, that is called as 2% settling time. So all these responses, all these explanations I will give with respect to maybe some 2 or 3 different types of numericals. So wait for lecture number 25. So I have uploaded lecture number 27 and 28. In lecture number 25 and 26, which is yet to be done, we have taken that in the class, but not happy with it, so I will record it and upload it today. Okay, that's all from my side today.